Well, welcome back to our second part of our sign making video. In the first part of this presentation, you would have seen us create all the vectors that we needed to create our sign. Now we've taken a bit of time in between to actually separate all of the parts up onto different sheets. Not to worry though, we still have to create one more sheet, so you're going to learn all about how to do that in this next little bit. Anyway, let's get started.
Yeah, right then. So we're in the file. So you can see we've got all of our sheets laid out. Now we're going to focus on creating our toolpaths for each of these sheets. And because we are creating a sign that has parts that slot into other parts, the best way to do this is to machine the plugs first, and then we can use those plugs to test the fit of the pockets. So this is mostly what we're talking about here is our inlays. So we're going to start by looking at our walnut sheet over here. So Victor's badge. So this is ultimately going to slot into a pocket on the MDF. So over here we can see that we've got our vectors and we've got the actual banner as well. So we're using walnuts, this material here. So we've got a job that's 13 by 5 by 0.23 thick. And we go over to our toolpaths tab. So the first thing that we're going to do is we're actually going to look at doing a simple V-carven toolpath on the Victor's text. So with that selected, we're going to go into the V-carve toolpath. Here we're going to set the start depth of 0. We're going to use a 60-degree half-inch V-bit. We are not going to use any clearance tools in this case. And then we simply go ahead and press calculate. We can see our previews come up there, and then if we go ahead and preview that, you can see what that looks like.
Nice.
Yeah, I really like this font, and with the V-carving, it's nice because it leaves those little portions up just to give it that little bit extra depth. Right then, so that's the easy bit. So if we put our vectors back on, so next up we're going to look at cutting this out. Now, as we are working with this project as using inlays, we're not going to profile this out like using a standard profile. We're going to use the profile that's in the inlay toolpath. And there is a very valid reason why we're doing this. So if we go in there, and we'll just kind of talk about that as we go into the toolpath. So here you're presented with options. Are you doing the male part, or are you doing the female portion of that sign? In this case, we're actually doing the male insert, okay? And we're going to go with a straight insert. And when we click on that, that's just going to open up the insert toolpath for us for this particular part. So here we're going to cut all the way through our material. So I'm going to put in there Z equals, and that will pull out the thickness of our material. And then what we're going to do is we're going to select our tool. So we're going to use a 1/4 inch end mill here. We're going to use that. I'm just going to do that in one pass. And then what we could do is we could just go ahead and press calculate over here. And then we can preview that, okay? Now I'm going to go into the 2D view because I want to show you what this looks like. And why, more importantly, why we're using the inlay toolpath. So the inlay toolpath, it enables us to factor in the radius of your tool against the vector. So when it cuts it out, it knows that when we cut the male portion out, when we cut the female version of that, everything is going to fit together. So you can see here, it's actually compensated here because we know that when we come to create the pocket version of this, we know that the internal corner here, that tool is not going to fit in, which we can see right here. And so for the male portion of this, it's already taking that into consideration, and so it's like overcutting that. And so this is why we are using the inlay toolpath over a profile and a pocket.
If you try to do that on your own, there'd be lots to think about, and this actually takes care of a lot of the thinking for you as long as you follow a few rules, which Becky will get to as we go. But yeah, it makes it much easier.
Yes, exactly. And so that will be pretty much cut out there. Happy with the way that that looks. And so I think now we can move on to look at another sheet that we're working with. So let's just close out here. We'll go into our 2D view. And what we'll do is we'll move on to our foam, because again, we are working with parts that need to be inserted into our MDF base. Okay, so we're going to go into our foam sheet. So here, what we're going to do is we're going to look at using this foam. So it's HDU is quite commonly used in sign making for its sort of lightweight properties. It's really easy to cut into. You can be quite aggressive with this material. And so what we're going to do is we're going to cut these letters out. We also have these 3D stars, and these 3D stars we've used pretty much from the clip art that's going to be included in your bundle. So just simple stars, and you can see they look pretty nice. We intend to finish our foam in a gold sort of paint, whether that's spray paint or like brush paint. We're yet to sort of figure that one out. Yeah. So what we're going to do is we're going to take our toolpaths. So we're going to take our vectors, and the first thing that we need to do is we need to, because of how bulky this is, we need to really sort of bring this right down, which is why we've got this vector that sort of goes off of our job space here. So we're going to take that vector here, and then what we're going to do, but before we do any of that, we should check our material setup. Okay, so we're working with 2-inch thick material. We're setting XY lower left, Z0 on the top, and then our model position in the material, you can see that we've got a gap below of 0.1, which is going to be handy because we can use that then to cut our stars out and then have those 0.1.
Yeah, so it's going to thicken it up a little bit at the bottom. Exactly, going to make them nice and robust. Because if not, that's right now the stars come right down to the modeling plane, which are going to be really thin on the corner. So this is a great little technique to thicken them up a little bit. And seeing as you're using double-sided tape to hold them down, you won't have tabs in there. So that'll, this will be nice. Yeah,
that's a great point there, Todd. We will be using double-sided tape. It's kind of become one of our favourite hold-down systems now, isn't it?
Definitely, yeah.
Right then, so we'll go through that. So we're going to start off by taking that vector. We're going to go into the pocket toolpath, in which case what we're going to do is we're going to cut down, we're going to start at 0, but we're going to cut down 1.5 inches, whereby we're going to use a 1/2 inch end mill in there. And then we simply just go ahead and calculate. There's not too much to see here. All we're doing is just trying to really reduce that thickness down.
Yeah, it would have been better if we could have sourced some thinner stuff, but unfortunately our supplier only has this either 50mm or 100mm foam. So anyway, it's kind of, we have to work with what we have.
That's it. We've got the tools and the software to sort that out.
That's right, exactly.
Right then, so that's now sort of thinned down in the software. So now what we can do is we can start to think about the other toolpaths. In which case we're going to start with our 3D machining. So we're going to take those vectors for the stars. I'm actually just going to group them together. And then we're going to go straight into a 3D finished toolpath. Now, because they're so small, we are working with foam. I'm not going to do a 3D roughened toolpath. I think this tool will be able to handle this strategy all fine on its own.
Yeah, definitely, yeah.
So we're going to use a tapered ball nose here, okay? So that's, we've got that selected in here. We're going to use the selected vector as our boundary, whereby we're going to offset ever so slightly so it cuts past the edge of our stars, and then we'll just give that a name. We'll just call that 3D finish. In an offset strategy, you could go ahead and calculate that.
That's a great tip to overshoot your actual 3D component like that. So that way when you do your profile cut, you're going to have a nice clean cut around the outside edge. So that's a great tip. Good job.
Okay, so that's our finished part done. So if we switch on the visibility of our vectors. Right then, next up we're going to look at creating the inlaid text for the saloon letters. But what we want to do is we actually want to look at sort of breaking this out, because we want to V-carve into all of these details there, and it's going to hopefully give us a nice effect when we come to machine that. So we're going to ungroup this. Actually, we're not going to ungroup it because it's not groups. What we need to do is convert it to curves. So if we go over to our design tab, and we're going to click on this button here, and that's going to convert our text to curves. Remembering that once you do this, this is no longer a text entity, and the software now sees it as vectors. And then what I'm going to do is we're just going to take all of these parts here. So I'm just using Shift to select them, and I'm going to group them. So we've got the actual inlay vectors as a group, and then what I can do then is I can select all of the internal parts and group those, which is what we're going to use to V-carve with.
Nice touch.
Yeah. So we're going to switch back over to our toolpaths, and with those vectors selected, we're going to go into our V-carve toolpath. Now remember, because we've already machined down 1.5 inches, we're going to set our start depth to 1.5 inches. We're going to use a 60-degree 1/2 inch V-bit. We don't need a clearance tool here, so I'm just going to take that out. And then what we're going to do is just go ahead and press calculate, and then we can preview that, see the effect of that. That's looking pretty good. And then what we can do is we can close out, and then we'll move on to the inlaid text. Okay, so we're going to take those vectors there. We're going to go back into our inlay toolpath using a straight inlay. Again, we want to set our start depth there to 1.5 inches, and then we're going to cut all the way down to the bottom, so another 1/2 inch. And then for this, we're going to use a 1/16 inch end mill. Now, it's really good to note that when you are working with inlays, you want to make sure that you are using the same tool for both the male and the female parts, to ensure that you're going to get an absolute correct fit. If you don't do that, it's just not going to work. Now, because we are also working with foam, I think we can be a little bit more aggressive on our settings for our tool. So here I'm actually just going to increase our pass depth to 1/4 inch. Having done some testing with this before, I know it's safe to do so, but as always, you should ensure that your settings are appropriate for the tools, materials, and machines that you are using. Okie dokie, so we're going to go in there and we can go and calculate that, because that's pretty much everything we need to do to set this up. And then we could go and preview that, and then that's what our text would look like. Okay, that's really nice. And then finally, we just need to think about cutting those stars out. So we'll switch on those vectors, and then we'll take those vectors there, go into our profile toolpath. Again, 1.5 start depth. And then here, we're just going to cut down to the rest right to the bottom there. We're going to use the select option, and we're going to go in again with that 1/16 inch bit. We'll select it, and then again, let's just edit the pass depth there to 1/4. And we'll go ahead and press OK on the outside. And then what we can do is we could go ahead and press calculate, and then we can preview that. And there we have our inlaid parts ready to insert into our MDF.
Looks really, really good. Looks really nice.
Thank you.
Nice, nice, nice.
Hopefully the gold will really sort of, you know, bring the text out on top of the MDF.
I love the way you kept those little internal vectors on the letters too, because it gives us a bit of interest with your V-bit. So again, some 2.5D cutting happening here that really add a lot of interest to it, which is kind of nice. Little details like that make a huge difference with signs.
Yeah, absolutely. Right then, so we're just going to close out here, and let's go to our 2D view so we can take a look at where we're at with our sheets. Okay, so we've done the badge, we've done the saloon text and the stars, so now we can start to think about the base that they need to slot into. So what we're going to do is we're going to go over to our MDF. Okay, so here you can see we've got the vector for the badge, we've got our saloon text minus the V-carve details, because we don't actually need to do that. So we've obviously already tweaked this, ready to start toolpathing. And we've also got an extra vector up here. Now, this is a profile that we're going to use with the molding toolpath. So we're going to use the molding toolpath to cut a nice profile around the edge. So hopefully it just gives it another element of dimension to the overall sign. I
love the molding toolpath. I like using it wherever I can. It saves a lot of time. And if you don't have the ability to 3D model, it can come in really handy.
Absolutely. Right then, so with that, we're going to start by looking at our pocket inlay. Okay, so we're going to go over to our inlay toolpath. Okay, so we've worked through the insert toolpath, so now we're on the pocket toolpath. So we're going to use the pocket toolpath here, and then what we're going to do is we're going to specify our start depth, our cut depth. Okay, so we're starting this at 0. It's probably worth pointing out actually that we are working with MDF that's 0.472 with the intention that we're going to paint it red. So we're going to go back into the inlay, take that pocket, okay, and we're going to set our start depth here to 0. And then what we're going to do is we're going to cut down 1/8 of an inch. So that just gives it enough that our badge can slot in there, but it's not going to be too deep because obviously the walnut is only thin anyway. And it will just give it that nice lift. Right then, so in terms of our tooling, so you'll remember we used a 1/4 inch tool to cut the plug for this badge, so we must make sure that we use that same tool, otherwise this is not going to work. So we're going to select that tool and then that's essentially going to cut that out. Now it's important to note here that when you are cutting your pockets, what you want to do is you want to include an overcut distance. So with all inlays, with all slot together projects, you need to ensure that the pockets are going to have a slight overcut in order for the plugs to actually fit in. Otherwise, if you don't have that, it will never fit in.
That's right, exactly, yeah, because all materials cut just a little bit different. You might have a little bit of wear in your tool that you haven't really accounted for. And also, don't forget, if you're going to finish these with any kind of finish, paint, shellac, whatever it is, that's going to make these parts, even after you sand them, which will make things a bit smaller, they're going to get a bit bigger again. Yeah. So you really are going to want to think this through to make sure you get a nice fitting part once they're all finished up. And the beauty of this whole inlay thing is that you can finish these and be kind of messy, right? You can make a mess with your shellac or whatever on this, but once you put it into your background, it's going to look perfect because you've got those nice straight edges. It's going to look really good. So it makes finishing a lot easier.
Yeah, definitely. And again, it goes back to what we were saying about how important it is when you are working with inlays to cut the plugs first.
Exactly, yeah.
You can finish those and then you've got them there to then test fit the pocket, which is what we're about to do now. And I'm going to go with a distance, an overcut distance that, you know, has worked for me in the past. It's worked for me in tests, which is 0.006. It's going to overcut by that amount. And it should give us enough wiggle room that we can easily slot those parts in. So we'll go ahead and calculate that. Okay, so I'm just going to go to the 2D view because I just want to show you that. Okay, so here's our overcut. So this is in the solid view. You can toggle between the wireframe or the solid view. So this is solid view. You can see it's definitely overcut. So we know it's done that there. And then again, going back to why we use the Inlay toolpath, you can see that this purple area matches the exact sort of cut that we did for the badge itself. Okay, so in the 3D view, we can go ahead and preview that. That's what our part would look like. Once you've cut that on the machine, whilst it's still on the machine, you're going to take that badge, or the plug, and at which point you can test the fit. If it doesn't fit, then whilst it's still on the machine, we can just make tiny adjustments to that overcut distance, making it a little bit bigger every time until you're happy with that fit. Right then, so that's the badge. So what we're going to do now is we're going to do the same for our text. Okay, so we're going to go back into the Inlay toolpath. The reason I'm doing this in two separate ones is because you'll remember we actually cut them out in different tools. We didn't use a 1/4 inch end mill here. We're actually going to use a 16th inch bit is what we used. So we're just going to remove that. But because obviously a 16th inch bit is very tiny, I'm actually also going to apply a clearance of an 1/8 inch tool as well. So we're going to select that and then we're also going to apply our 16th inch bit, and that should just get around at the details that 1/8 inch bit could never get to. Okay, so again we want to put in that overcut distance here, and then we could go ahead and calculate that. Okay, so let's do the clearance first with that 1/8 inch bit. So there we go, and then blink and you'll miss it. We've just got this 16th inch bit, and you can see it is just going around the edge. But if you go ahead and preview that, you can see it just gets in at those tiny details. Yeah,
clearance tools are great to save time as well. You can actually get in there. If you had to use the that smaller bit to do all of that with, you would have been a much longer time than going in with that bigger bit. So it's if you have a chance to use a clearance tool, consider it for sure.
save yourself the time. Okay then, so that's pretty much the inlay parts done. So what we're going to do now is we're going to look at the moulding toolpath, okay? So the moulding toolpath, let's open that up. So that's this one over here. So this enables us to assign a rail and a profile that we can use to create almost 3D profile parts. In which case, what we're going to do is we're going to use this vector as our rail, and you'll see that I've included this profile here, okay? So what will happen is we're going to essentially attach this profile to this rail over here, and it's going to give us this nice curvature, and it's going to have a flat bottom and then drop down again with another flat bottom, and then this portion here is just the it's enough that it's going to fit my 1/4 inch tool that I'm going to use to create that with. So we've got our rail, we need to shift and select our profile over here. I want to make sure that that profile is pushed all the way up to the top of our material also. And so here we're going to do this in 2 strategies. So we're going to do that using a tapered ball nose bit to get our curvature, but we're also going to look at clearing all of the flat areas out prior to using that ball nose tool with an end mill. And so in which case what we want to do is we want to use a 1/4 inch tool for that clearance, but we want to make sure that we're actually machining those flat regions. And then with that, we want to make sure that when we get to our ball nose tool, that we actually skip those flat regions, because there's no point in us going over that again. And as well, it's going to ensure that you're going to have much flatter areas with the flat bottom bit than with a ball nose. Okay, and then what we can do is we want to have a machining allowance as well, so that we have enough bite for that tapered ball nose to eat in at when we come to do the finish. Then we could go ahead and press calculate, and we can see what that would look like. Then here we could go in with our clearance preview, which will look something like this. And then we'll go in with our tapered bit, and then you can see we've got this nice curvature there. Nice.
That looks really good. When Beki did her actual molding toolpath, she did skip over a tiny section there that she accounted for when she created her vector, which is the, I can't read from here because of my old eyes.
As a step over.
No, the one near the very bottom, the boundary offset.
Oh,
exactly,
yes.
Yeah. So if she had have included in the automatic boundary offset, it actually would have gone even wider outside of that vector profile, which isn't what you wanted to do. If you did that, then you may end up marking the top of your material or going way outside that second line. That we didn't want to go that far. So when you do play with this, if you do get into it, make sure you pay attention to what check boxes you're checking down there.
Thank you.
You're welcome.
All right then, so we're just going to close out there, and then we're going to take this vector. So all we're doing now is just cutting this part out. So we're going to take that, go into the profile toolpath. We're going to cut all the way through our material. So we'll do a Z equals in there. We're going to change out that tool. We do not want to use that 16th inch bit. We're going to use a 1/4 inch bit. We're going to machine that on the outside, and then what we'll do is we'll also add in some tabs in here as well. So we'll go and edit the tabs. Let's just put 3 in there. We'll just let the software figure that out. So there they are. And then what we can do is we could just go ahead and calculate that, and then we can preview it, and then that's what that will ultimately look like. Okay, so that's pretty much the MDF base. Now I'm going to cover one more thing before I hand over to Todd, and that is another 3D element that we want to include. So if we go back to our design sheet over here, I want to include some clip art that we're just going to cut standalone and then essentially just stick that on top here. So what I want to do, if we just switch over to our toolpaths tab, I just want to draw out just a rough box, just so I know sort of the dimensions that I'm working with. Okay, so it's kind of got like 6 by 3.5. Let's go with that. So close out, delete that. And then what I'm going to do is I'm going to create a new sheet. Okay.
I like that technique of boxing off the area that you've got so you can size everything up and you know it's going to fit. Nice.
Yeah, it's super handy when you're working with complicated jobs like this. Right then, so we're going to be working with beach in this case. Okay, so I'm going to go in here. I'm going to edit this sheet. I'm going to edit this so that my sheet is actually the size that I just kind of pulled out there. So it was like 6 by 3.5 inches. And then in terms of my material thickness, the actual thickness of the material we are using is just shy of 1 inch. So as E0 to the top, XY lower left. And we're going to work with a very high modeling resolution because we are going to be working with 3D. So we want to just, increase and maximize the amount of pixels that we've got within our job. And then in here, we'll go with a beach setting in here so that it kind of matches what we've got. And then we'll go ahead and press OK.
It's important to note that when Rebecca went to edit that sheet, she didn't go to her job setup tab. She did it right within inside of her sheet navigation window here. That way she wasn't, if you did it the other way, it would have affected all of the sheets, and we don't want that. This is actually just affecting this one sheet. So it's good if you end up noticing all of your sheets size up all of a sudden, then that's the problem. You need to go back and fix that.
Absolutely. Yeah, you don't want to do that.
No.
Right then, so now we've got our beach sheet organised. What we can do now is we can go to our clip art. We're just going to our 3D view over here. And then what we're going to do is we're going to go to our UGM folder, and I'm just going to double click on the cowboy hat and cat tie. I think that's going to be a nice fit there. What we want to do is we just want to make sure we size that so it fits within our job. Fairly happy with what we've got there. Now what I want to do here is I want to machine it so that I want to position the model in our block of material so it's pretty much at the bottom, okay? And so what I want to do is I want to ensure that we can hold it together when we're actually cutting that out. And so I'm going to, rather than using because we're doing a 3D toolpaths on it, 3D roughing, 3D finishing, and with that model being pushed right to the bottom of my material block, when we cut that out, ultimately it's got nothing really to hold on to in terms of, how we position tabs. So we're going to look at applying 3D tabs that we're going to slot in here, and that's going to help figure all of that out. So before we create our tabs, what I should do is I should create a vector boundary of what the composition that we've got currently so far. So in here, we're going to use this little handy button here. That's going to create a vector for us. If we just switch on our vectors, we can see that there. Okay, so what I'd like to do is machine everything inside of the vectors. However, I want to get rid of these island vectors because I want that 3D finish to cut all the way through there. I don't want there to be islands left out. So we just need to tweak that vector ever so slightly. So we're going to go over, and what we're going to do is we're just going to ungroup those vectors, and then I'm just going to shift and select the outer vector, and I'm just going to delete those two vectors. It might help if we just undraw the visibility of our 3D model. But I also want to look at just tweaking this slightly because I don't want to have an island left here either. I want to machine all the way through this. I'm just going to tweak this ever so slightly by going into node edit mode. And then here I'm just going to look at cutting this vector. So I'm just going to press C to cut that. If we go C over here to cut that there, C there, okay. So that's done that, and then we should be left with that, which I can go ahead and delete. Let's right click to come out of node edit mode, and we're just going to look at joining this up, just using a very small curve there. Nice. And then if we switch our model on, you can see that it's not going to be interfered at all.
To group and ungroup, is it G and U on the keyboard?
G and U, yes.
Okay, right on. You did it quite quick there, and I was... I don't use those quick cues very often. Usually I go to right click a group and so on. So yeah. Yeah. Yes.
Shortcut keys get you through the job faster, Todd.
That's right. Exactly.
Right then, so let's go and add in some tabs. So in your clip art tab, you should be familiar with the 3D tabs. So we're just going to look at bringing that in like so. Okay, we can just, we don't need them so big, do we? And then we can see we can just slot them in like so. I'm using Control now to create a copy, like so, and then I'm going to go and press Control again to create another one and just kind of move that.
Yeah, the 3D tabs are included in your clip art that you get with your software. So if you don't see it in there, you just need to log into your V&Co account and download the installer for them.
Yeah. And you can see they're just shy of 0.1, so I'm kind of happy with what we've got there. So in terms of the composition, happy with that. I think we're ready to then go ahead and run through our toolpaths. So we're going to take that vector as our boundary. We're going to first run through a 3D finish toolpath, okay? Now, because we haven't actually set up our material yet, our material setup form is automatically open because we need to tell the software where that model is going to be in terms of our material, which I said I wanted to push it all the way down to the bottom there. Okay, and then everything else looks pretty good, so we could go ahead and press OK. Okay, so we're going to use a 1/4 inch end mill. We're going to use the vector as our boundary whilst also maintaining an offset so it cuts past that part with an allowance so that our 3D finish toolpath can have a little bit to bite onto. We can do this in a Z-level strategy. We could go ahead and calculate that and then we can preview that.
Yeah, what's nice about the roughing bit is you're removing most of that material that you don't want that very delicate finishing bit to have to cut through, especially in beech or a hardwood. Unlike the foam, you are going to want to do that roughing toolpath for sure. Yeah,
absolutely. So then we close out there because we're happy with what that looks like. And we're going to go into our 3D finish tool. We've still got our vector selected. And then this time we're going to use a tapered ball nose bit. Okay, so it's going to be a 16th inch sort of total tapered diameter. And again, selected vector with a little bit of an offset. I'm going to do that in a raster strategy, so it's going to go back and forth. And then we could go ahead and press calculate. And the software will just take a moment to figure that out. And then it can cut that out. And you can see that because we've pushed the model all the way to the bottom, remember, in theory, there is actually nothing there. But the way that this is kind of computed that preview, because we are using a radius tool, we can see that it's cut through. But the reality is that we won't really see any of that material there. And we can see that we've cut through. We've got our tabs in place. So pretty much safe to go there.
Wow, that was a lot of stuff.
That was a lot of stuff. I'm going to hand over to you now, Todd.
Oh, thanks. Okay, so save that off someplace where I can find it, and I'll jump right into it. Okay, so as you can see, I've got that file that Rebecca just saved off already open here, and we're ready to go. So we can start to think about the missing pieces that we haven't created yet. So if we go back to our original design, Rebecca took care of everything that's in the middle, the red bits. And so I'm going to go ahead and do this area outside here, which we're going to create a Velcro mat. And then we're going to talk about the background. So let's have a look at the sheet that's called Velcro mat. Now, this is one of the materials that I believe Rebecca found quite a while ago. And it's a black MDF. And typically we would paint it white on one side. And this comes in really handy if you're going to do things like photo V carving, sketch carving, where you cut away the white surface and you end up with the black inside kind of showing. It's really a nice material to use.
Yeah, it really is.
So we're going to use this for the outside ring of the Victor's saloon. So we've got some vectors already set up here. Now this inside vector, this is where we're going to actually inlay in the red MDF that we hopefully will paint and stick in the middle. And then we've got two vectors here for V carving, and then we're also going to V carve these circles. So let's start off in our 3D view and we'll turn on our vectors. You'll see that I've decided to color the material gray because looking at it in black, it's really hard to see with black vectors, so that wasn't a good idea. So we're going to pretend the gray is black, and that's what it's going to be in the end. So let's grab this inside circle, jump over to our toolpaths tab, and this is going to be a very simple pocket. We're going to go ahead and use a start depth of 0, so right on the material surface, and we're going to go down 0.13 of an inch, and we're going to use a 1/4 inch end mill. We're going to offset tooling, and we're just going to cut that out. That's going to give us a nice little spot to plunk our center bit.
We also Could do with a little bit of an allowance, Todd.
Oh, that's right, exactly. All the talk we've done about inlays, and here Todd went and forgot the actual pocket allowance. Let's turn this back to gray for a second so we can take a look. Oh, sorry, the material color should be gray, not that. There we go, make that dark gray. There we go, that's better, perfect. Okay, let's go back into that again. Exactly, Rebecca, we need to go ahead and put in our allowance. Now, because we're not using the inlay toolpath, we need to make this a negative allowance. So minus 0.006, that's Rebecca's magic number. That's gonna make sure all these parts fit in together. So we'll recalculate that again, and we'll preview that toolpath again. And it should just get slightly bigger. You saw it just get a hair bigger, just enough room to give us that little bit of wiggle room. Thank you for pointing that out to me.
No problem at all. And as well, the reason why we're not using the inlay toolpath here is because it's just a circle. So we don't need to use the inlay. A pocket and a profile will just work perfectly.
Exactly, yeah, that's right. Okay, the next little bit we're gonna do is we're gonna choose these two vectors here, and we're gonna create a V-carve toolpath. And we're just gonna V-carve down a bit, no flat depth at all. We're just gonna go down as far as our tool will fit between those two lines. We are going to use that 60-degree and V-bit, excuse me, and we're not going to use a clearance tool because there's no need for that. It's a pretty small area, and we'll just go ahead and calculate that, and then we'll preview that visible toolpath. And there we have that nice little detail in there, and it's the little details that make a difference, like we said earlier. Okay, now the last little bit we're going to do is we're going to look at these circles. So we're going to grab these, and these have all been pre-grouped together for us, which is nice, and we are going to use a V-carve toolpath. We're gonna have a start depth of 0. We're gonna go down to a flat depth of 0.1. We're gonna use that 60-degree V-bit, and we're gonna use a clearance tool this time. We don't wanna bother to clear these all out with that V-bit. We're gonna waste a lot of time. So going in with this end mill, first of all, to clear out the middle of the circle, and then do the edge is gonna be the way to go. That looks great. We can just go ahead and calculate that, and we'll preview that visible toolpath. And they look great, and because of the nature of that V-bit, we're gonna get that nice angle on there, which is gonna look really sharp, I think.
Yeah, and then when we go and machine that, even though it's outputted the toolpath as clearance first, then the V-carve, we're actually going to look at running the V-carve toolpath first, followed by the clearance, because that's gonna give us a nice clearer cut.
Exactly, that's right, exactly. No chipping and so on, which we shouldn't see anyways in MDF, but in hardwood, definitely you'd see a problem. So, okay, let's close this down. And the last toolpath is gonna be, oh, sorry, we're going back to our 3D view again, turn on our 2D vectors. We're gonna grab this outside vector, and we are gonna create a profile toolpath, and we're gonna cut all the way through our material. So that's just gonna be Z, and we can go equals. That's perfect. We're gonna use an end mill. We're gonna go outside that line. We're gonna add in some tabs. We'll edit those tabs, and we'll be brought over to our 2D view. I'm just gonna drop in some quick tabs here where I think they should go. That's great. Close that down. That looks good, and we'll calculate that, and then we can preview that visible toolpath. And there we have it. Cool. That's gonna be really nice, and hopefully everything will fit in perfectly. Okay, so let's go back to our 2D view again, and we'll take a look at this last sheet over here. Actually, we have two more sheets. We've got this one, which is what we're gonna use to make the background of this whole sign. And I've decided that we're gonna use some of this pine that we have. Now, I couldn't get a piece big enough, so I had to put two pieces together. And I'm not going to explain how I did that, because you're going to find your own ways of doing that. But in the end, I'm going to need to come up with some kind of a way to do that. So you might see me doing some kind of a weird joining thing later on. But for right now, I'm not sure how I'm going to tackle that. So we're just going to go ahead and jump right into this, pretending it's one solid board. So we've got this. The first thing we're going to want to do is to think about the pocket that we're going to inlay that piece we just saw being made into. That way we can, like Rebecca said, we can have that piece set aside. We can bring it over after we cut this pocket and test it in place. So let's do that first. We're gonna go ahead and close this down for a sec. We're gonna use a pocket toolpath. Let's turn back on our vectors. Sometimes even though you have a vector selected and you have your vectors turned off, you can't tell that it's selected. So be sure that you have it turned on so you can see what's selected or not selected. We'll pocket down. We're gonna go down 0.15 of an inch, and we are gonna use a 1/4 inch end mill. That's perfectly fine. That's all good. And we're gonna make sure that we put in that pocket allowance, because we wanna make it a bit bigger again. So again, minus 0.006, and then we can calculate that, and we'll see what we get, and we'll preview that visible toolpath. That looks pretty good, except for I think I'm going to need to go a little bit deeper, because the next step, I'm going to wipe most of that away. So let's go back into that toolpath again, and we're going to make that a 1/4 inch down. And we'll preview that. We'll recalculate that, and then we'll preview that. That's what's lovely about our 3D preview, is instantly I could tell that that wasn't quite deep enough.
Yeah.
So I'm going to go back and fix that right away.
So what you see is what you get, Todd.
100%, that's right, exactly. And I didn't want to get that, so this is good. So let's go back and turn back on our 2D vectors. Now the next thing I want to think about is what I want to do with the edge around here. There's all kinds of different things we could do with that. We could use a molding toolpath like you did earlier. We could use a 3D component. We could use a V-bit and just do a nice little chamfer on that if we wanted to. But I thought it'd be fun to play around with a form tool, and I'd done this a few years ago, but I thought I'd tackle it again with a new form tool. This one is interesting. It has the ability to be able to plunge cut, so I can actually plunge right into the material and do a pass around it and give me a nice edge. This is a nice little tool, I think. So it comes with all of the measurements right on the tin, if you will. But first of all, we're going to need to get this added into my tool database. And to do that, I'm going to need to have a profile vector of the actual shape of this tool. Most of the time, you'll be able to get that from the actual tool vendor. In my case, I needed to draw it, and I've exported that out as a DXF file. So I'm quickly going to import that in right away.
And this is quite typical, isn't it, of form tools? You can get hold of the digital profile to bring that into your software.
Exactly, that's right. Yeah, so you just need a basic DXF file or EPS file or whatever they give you. And there it is right there. A couple of important things about this vector is that it's the right-hand side of your tool, and there's no top vector to it. So it's just the profile along to the bottom. And your software will use this to generate a preview of what you should see in the end. So with that in there, I'm going to go over to I need to select that first of all, and we'll go into my tool database. And I'll just slide this aside. That looks good. That's just I want to be able to see this profile vector in the background. So if I go down to my form tools and I quickly go ahead and add a new tool, and I choose form tool out of the type that I have here, you'll see that the software will automatically draw the whole profile of my tool. And you can kind of make sure that it matches up. And if it does, I think that's pretty good. I'm going to go from that, and I'm going to copy some of my tooling or my feeds and speeds from another tool. And I'm just going to double check this all to make sure that it's okay. So we've got pass depth, it seems okay. It's about 1 inch or 1/2 inch tall, so that's about right. Step over looks good. Feeds and speeds, I'm pretty comfortable with that. What you're going to want to do is to cut a test part, and that way you can actually see how your tool is going to react, and then you can adjust your tool in your tool database appropriately for that. So we're just going to go for this right now. We'll apply that and we'll click OK. So that's in there now. So let's create a profile toolpath using this outside vector. I'm going to run this tool along that vector, so it should give me a nice profile. I'm going to get both sides of it, but we're actually going to cut away half of that because we're not going to keep the whole thing. So we're going to have a start depth of 0.15, and that's going to make sense in a minute because I'm going to add a bit of a texture to the top of this thing, and I'm going to cut down that deep, and if not more, so that's great. Cut depth, we're going to go down the whole depth of the tool. So in this case, this is a millimeters tool, and I'm going to show you a really cool tip to make sure that you get your dimensions right in here. So this says 12.7 millimeters is my cut depth. So if I put in 12.7 and I multiply that by I, so it's going to convert the millimeters into inches. I press equals, and it's about a 1/2 inch.
Top tip. And you can do the same in reverse. If you were in a metric job, you would times it by
M. Yeah, exactly. Yeah. Exactly. Yeah, to bring it back to millimeters from inches, which is great. Doing maths in your fields is really quite good, and it's really quite helpful as you're doing things. So that's good. So we're going to show. That's fine. We'll leave that turned on. We are going to select the tool, the form tool that we want. So we'll select that. We're going to go on that vector, as I said, which is perfect. And we're just going to go ahead and calculate that, and we're going to see what we get when we preview that. Okay, so that's pretty nice. Yeah, that looks pretty good. Okay, now like I had said a minute ago, we're going to add in a bit of a texture. So that start depth that I pointed out is going to make sense now. We're going to just go ahead and reset my preview so that I don't see all of that preview already. There we go, that's great. Because what I want to do is I want to create a texture using our texture toolpath. And one of the things I've learned from doing this, and if you want more information on this, by the way, we've done a couple recent projects, free project you can download. One is the dart box that David and I did. I used the texture toolpath for that, and I also used it for the clock that I did, along with the vector texture creator, which is kind of handy to have. But for right now, we're not going to get into that. So what I want to do is I want to create my texture between these two vectors, knowing that I'm actually going to be removing some of the texture outside. That'll give me a nice straight edge to my texture, which is going to look really good in the end. And on this side, on the inside, of course, I've got this pocket here, so I'm going to cut that straight anyway, so it's not going to matter. So let's go into our texture toolpath, and we are going to use this big 1/2 inch ball nose that I happen to have here, which I've used before, and it's done me good, so I'm going to use that. We're going to have a start depth of, there's that 0.15 I spoke about earlier. Now I could use some vectors like I did for the clock project, but I'm not going to do that. I'm actually just going to texture between these two vectors using the settings that are here. And what's nice about this is it's going to give me kind of an organic looking texture in the end. And every time I go to recalculate my toolpath, it will regenerate this, throwing in some different variables to kind of mix it up a little bit different every time. So keep that in mind. If you come up with one that you like, then use this save button right here and you can save off those settings. Okay, so we're going to start off with our cut depth is going to be 0.15. So we're going to go down 0.15 again at the max. So it's going to go in and out a little bit from that. Our cut length is going to be 4 inches long. So, and along with some variation in here. So it's going to do some fun stuff there with that. The overlap is going to be 15% of my tool, plus again, some variation in there. So it's going to mix it up a bit for me. My step over, which is going to be how much each line sort of steps over each other, 0.35 an inch with some variation in there. I'm going to leave it with no angle. I want it to go back and forth, which I think will look really nice. I'm not going to use any boundary offset. I could use that if I want to go outside of these lines, but I've chosen these on purpose. I don't want to go inside this line if I can avoid it, just in case. And we'll just go ahead and calculate that. And we'll preview that visible toolpath and we'll see what we get.
Nice.
Now that looks good. So now what we want to do again is we need to preview this to make sure everything kind of all matches. So let's go back to our pocket for our center. Not that we're going to run this in this order, but I want to see the end result.
You can see it's done a nice clean
edge in there. I've got enough here to be able to hold that middle piece of Velcro mat in there and still have a lip, so it should cover up and look like it's all one thing, which would be nice. And then we're going to do this profile here. We'll preview that visible toolpath and we'll make sure that we go down far enough. And that's exactly what I want, is a little bit of a step here. That looks great. I think that's going to be pretty cool. So the last bit we're going to do is going to be the stars. Now this is going to be the same inlay technique that Rebecca showed quite often here. So I've got the stars. These are going to be the pockets. And then up here on this other sheet, these are going to be made of walnut. We've got our actual plugs set up here, or our male parts. So let's go ahead and go into our 3D view again, turn on our toolpaths, or our vectors, excuse me, and we'll go into our inlay toolpath. Now this is going to be a very easy, straight walled toolpath. We're going to start at 0. We're going to go down all the way down to our material. I'm going to use my small bit. It's going to be 1/8 inch. So I want to remember that. So when I create my pockets for these, that'll be the tool that I want to specify as the smallest bit in my set. We're going to go down 4 passes. That's fine. Everything else looks good. I'm going to be using double-sided tape to hold these in place, mainly because I think cleaning off tabs from these is going to be a real pain. So using double-sided tape might be the best option. Just keeping in mind to be really careful where these thin areas are. If the grain's running through there, they might break. So I don't want, I peel it off, I want to be very careful. And everything else looks really great. So we'll just go ahead and calculate that. Well, I don't have any vectors selected. So let's select those and then let's calculate that. And we'll preview those visible toolpaths. And I should have some nice looking stars. Now I'm going to want to cut these first before I cut the pine bit. That way I can test fit these in to make sure everything is happy.
Good practice.
Back to my 2D view a second, 2D view for a second, back to this. And let's go ahead and create the pockets for that inlay. Just close those down. And we're going to go in and have a look at that. This is going to be straight walled pockets. We're going to have a start depth. Now, remember when we created that texture, I started at 0.15. So we need to start at least 0.15 down. We'll go down again another 0.15. I think that makes sense. We'll use the 1/4 inch end mill to clear out some of this. Why not? It's there for me. And then the 1/8 inch end mill, again, that's going to get me all that fine detail that I need. And that's the small bit that I use for my stars. It's going to take 2 passes. That looks great. Let's just calculate that. And as Rebecca pointed out earlier, we're going to get 2 different tool paths. So if we preview this tool path first, we're going to get that. And then we're going to go in and we're going to clean it up a little bit. Now, I've reset my my preview, so I'm going to go ahead and just turn those all on so we can preview all that.
And as well, Todd, I think we need to put in that allowance for your inlay.
Good thing you're here. I would have messed it up again.
Forgotten.
Jeez, really, wow. Okay, so let's go and do that now.
But it'll save you a lot of time afterwards.
Exactly. There it is right there. Look at that. So this is the overcut distance. So this isn't a negative one. It's going to be a positive one. And there's that magic number. And we'll recalculate that.
Perfect.
That's a silly mistake, but as you said, easy to make. I've done it twice already. So let's close that down. Okay, that looks pretty good. The last and final toolpath we need to do is a cutout toolpath to get this thing out of our material. So let's grab this outside vector right here. Perfect. And we'll do a profile cut. And we're already down 0.3 of an inch, if not even farther than that. We're down 0.5 of an inch because then we've gone ahead and used that form tool. So all I want to do is go down Z minus 0.5, right? That makes sense. We're going to select the end mill, select that. We're going to go outside that line. That looks good, that's fine. We're going to add in some tabs, edit those tabs. We'll plunk in a few tabs on the straight areas here. Close that down. And that all looks good. We're going to calculate that. I think I've gone really deep. Nope, perfect, look at that.
You're good.
Yeah. Again. Previewing those visible toolpaths, when you're even second guessing yourself for a second, it helps to actually see that. Now I'm pretty happy with that, and I think we've got everything we need.
I think that looks great. I love the texture there, and that texture toolpath, you can be so random with it and it will create a real nice effect. And we said before that textures can be found in quite a lot of signs, and I think this is going to be a real nice addition to our sign. So I reckon we should save off all of our toolpaths. Let's get machining it.
I'm excited, let's do it. Wow, that turned out really nice, Rebecca, in the end. Everything we talked about, the contrast, the texture, everything looks really, really good.
Yeah, it really does. I love it. And you can get access to the file from the user group meeting bundle, along with a selection of 3D and 2D clip art as well.
Don't forget, we're going to have a live segment that you can ask any questions you'd like to. But until then, I hope you enjoy the user group meeting and can't wait to see what you make next.